All right, ladies and gentlemen, today we're going to take a look at section 1.5, which is examining different strategies to use when problem solving. So we're going to focus on a couple different approaches that we can take with these problems, and we're going to learn to identify which approach is going to work best given the situation that we're in. So let's take a look at the following 4 examples. Example 1 says a paramotor is a parachute propelled by a fan-like motor. The table shows the height h of a paramotorist T minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. So that is basically what we need to make sure that we are actually answering. So the first thing that I'm going to do, and I'm going to make myself a note of this, the first thing I'm going to do is try and look for patterns. So I'm going to go ahead, I'm going to take note of this, and then I'm going to examine any information that they're giving me. So I know when our time is 0, we're at a height of 2,000 feet. After 1 minute goes by, I've dropped down to 1,750 feet. So I'm going to say that this difference is negative 250 feet because I'm going in a downward direction. I notice that from 1 minute to 2 minutes, the difference is the same. So it's another 250 feet, another 250 feet, and so on. So since that pattern is constant, we're going down 250 feet each minute, I'm going to go ahead and try and use that to solve this problem. So I'm still looking for the height of the paramotorist after 7 minutes. One of the first things I can do, let me go ahead and change my pen color. I can go ahead and extend this table. Okay, so I can say 5 minutes, 6 minutes, 7 minutes, and I can go ahead and continue the pattern to find the value that we need. Now my second approach is I'm going to go ahead and kind of use a review of Algebra 1. I'm going to think back to writing an equation. And with the equation, one of the things that we want to focus on is the change per minute. So I'm going to go ahead and write that down. And if I think in terms of writing an equation, I know that this change per minute is going to be my slope. So I'm going to ask myself, what's changing? How is it changing each minute? And we see that that was already negative 250 feet. The other piece of information we need to know is where our starting point is at. So my highest point in this case, when t equals 0, when no time has gone by, is going to be 2,000. Okay, so hopefully we're going to be a little bit familiar with this. We know that our general equation is y equals mx plus b. I can type in y equals, my slope is negative 250. X is going to really represent time in this case. We're saying however many minutes go by plus our starting point. Okay, so if I go ahead, we want to know after 7 minutes. We always have to go back and make sure that we are answering the question that we're given. So if I go ahead and plug this in, negative 250 feet times that 7 minutes plus 2,000, I should get an answer of 250. So once 7 minutes has gone by, I'm going to be at a height, or the paramotorist is going to be at a height of 250 feet. So whether we looked for patterns and we finished writing that table, or we use this equation method, we should come up with the same answer. Okay, let's take a look at example 2. Example 2 gives us a picture. So anytime we're given an image, we want to make sure that we use it to the best of our ability. Number 2 says, you are hanging 4 championship banners on a wall in your school's gym. As I'm reading this, I'm also going to make sure that I'm underlining any important information. The banners are each 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners and between each pair of banners. How far apart should the banners be placed? So for this problem, we went ahead and were given an image to represent all the information given us in the problem. So I'm going to go ahead and write this out in an equation, but first I'm going to share one other method. One method that we can use is guess and check. Now, if we're ever truly stumped, we can go ahead and start plugging in different numbers for x to see which one is going to give us a total of 62. The only problem with that is that we're going to run into an issue if we're given decimals or if we're given fractions, something that's not a nice number. So anytime that we can rely on some regular good old-fashioned mathematics, we definitely want to take that route. So for this one, I'm going to go ahead and set up an equation again. Okay, and without overthinking this, I'm going to go ahead and say, well, I know that the total length has to equal the length of the banners, all the banners, plus the wall space. And as soon as I have this written down, I'm going to go ahead and fill in any values that I'm given. So I know that the total length of the wall is 62. I know that each banner, 1, 2, 3, 4, I know that for the 4 banners, they are each 8 feet wide. So I have 4 times 8, plus I have 1, 2, 3, 4, 5 pieces of wall space at some unknown length. As soon as I have something in this form, I can go ahead and simplify. I have 62 equals 4 times 8 is 32 plus 5x. Go ahead and subtract 32 from each side to get that variable by itself. So I have 30 equals 5x. We know that since we're multiplying, we want to go ahead and divide to get our variable by ourselves. And we should get an answer of x equals 6. Since x equals 6, we just need to make sure that we are actually answering the question. It says how far apart should the banners be placed. So I'm going to go ahead and add to this, and I'm just going to say 6 feet apart. And that is going to give us our final answer. Always make sure that you are answering that stated question. That is something that you could potentially get points taken off of, even if your math is correct. You always need to make sure you go back and check that your answer makes sense. Okay, please go ahead and take a look at number 3. Make sure that you are writing down any questions if you have them as they come up, so we can make sure that we go through those in class tomorrow. Number 3 says you are hanging 3 pictures on a wall in your home that is 16 feet wide. I'm going to go ahead and underline that. The widths of 3 pictures are 2 feet, 3 feet, and 4 feet. You want the space between the pictures to be the same, so to be equal, and for the spaces to the left and the right of the group of pictures to be 6 inches more than the space between. How should we position the pictures? Now, one thing that we're going to notice with this problem, number 3 is pretty close to number 2, except that we're not given a picture. So the first thing I'm going to want to do is to go ahead and make one. So I'm going to draw this out. I know that this wall has a total length of 16 feet. I'm going to go ahead and put a check mark up there because I know that I used that piece of information. I know that I have one image that's 2 feet wide, one image that's 3 feet wide, and one image that is 4 feet wide. Okay, I'm going to keep reading. You want the space between the pictures to be the same. I don't know what that space is, so I'm going to go ahead and call it x. So I have x and x. And now the tricky part of this, it says the space to the left and the right of the group of pictures to be 6 inches more. So I know that x represents some amount of feet, but I want it to be half a foot additional. So I'm going to go ahead and write this end space as x plus 0.5, where that 0.5 is half a foot. Okay, from here, this is going to be very similar. I'm going to write out a model where my total equals the pictures plus wall space. I know that the total length of the wall is 16 feet. The pictures are going to be 2 plus 3, which is 5, plus 4, which is 9, plus my wall space. So I'm going to come back over here. I'm going to change my colors again. My wall space is going to be x plus x. So that is 2x. Oops, nope, x plus x plus x plus x. So that is 4x. And then 0.5 plus 0.5 gives me 1. So if I'm combining like terms from here, I'm going to have 16 equals 10 plus 4x. Same thing as in problem 2. I'm going to go ahead and subtract 10 from each side. So I have 6 equals 4x. And of course, x is going to equal 1.5. Okay, I'm going to go ahead and follow my own advice. The question asks, how should you position the pictures? Since x equals 1.5 feet, I'm going to go ahead and write out the pictures should be 1.5 feet in between. And then 1.5 plus 0.5, so 2.0 feet on the outside. Okay, so always make sure that you have a good summary of what you are answering. This is 2.0 feet on the outside. All right, finally, number 4. We're getting really close to the end. Thank you guys for your patience today. Number 4 says a car used 16 gallons of gasoline and traveled a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway and 25 miles per gallon in the city. How many gallons of gasoline were used on the highway? One thing that's really nice about this problem is that we're given a verbal model. Okay, and this verbal model is kind of demonstrating for us where we can go ahead and plug in each piece of information. So I'm going to see that the total distance equals the highway fuel efficiency times the highway cost, and the city fuel efficiency times the city cost. Okay, and those costs may or may not be the same. So I'm going to go ahead and start filling in. I know based on the problem, my total distance is 460 miles. So I'm going to go ahead and write this out. I have 460 equals. Now remember, my first box is the fuel efficiency for the highway. So that is 30 miles per gallon. And then it says the number of gallons used. The number of gallons used. I don't know how many gallons I specifically used on the highway, even though I know I used 16 gallons of gasoline total. So I'm going to go ahead and call that G. It's still unknown to me at this point. Okay, now my next part says the fuel efficiency for city miles. So I'm going to come back up here. I see that it's 25 miles. Or 25 miles per gallon in the city. Now I have to be really careful because I need to know how many gallons I used in the city by the city alone. If I have 16 total and I subtract the amount of gallons I have in the highway, I don't really know what number this is going to be equal to, but I can go ahead and use it to our advantage. It's going to help me solve. Okay, so from here I can go ahead and start combining like terms and simplifying. So I have 460 equals 30G plus 25 times 16 is 400. 25 times negative G gives me negative 25G. So combining like terms, I can say 460 equals 5G plus 400. Simplifying, I get 60 equals 5G. And of course, 12 equals G. Okay, so there is my answer, but again, I have to make sure that I'm actually answering the question. This question says, how many gallons of gasoline were used on the highway? Okay, so I am looking specifically for the highway, which is my G. So I can say 12 equals the number of gallons on the highway. And if I were looking for how many city gallons we use, I would have to say, well, 16 minus G, and that would give me 4 gallons in the city. Okay. Ladies and gentlemen, at this point, I would like you to go back. If there's any particular problem that you felt that maybe didn't make complete sense to you, I would like you to try and watch it one more time. And on your note sheet, please note any questions that you want to ask. Okay, we're going to have some time in class to go through and really focus on specific parts of these questions. So if there's something that doesn't make sense to you, please make yourself a note. And if there's anything else I can do to assist you, please let me know. So have a good night. Thank you for doing this, and we will see you tomorrow.